This is the video presentation of %ASH, Analytical Services Method Number 3. %ASH is a proximate analysis test that gravimetrically determines the ash content of a sample by burning the sample in a muffle furnace oven. For analytical services, %ASH is usually a continuation of %moisture, Analytical Services Method 2. For this demonstration, we will begin the %ASH method where the %moisture ended. If you have not viewed the %moisture video, please review the method and follow all the steps before proceeding with the ash determination method. The %ASH method described here is based on these official methods. These official methods we refer to are suitable for meat, flour, animal feed, milk casein, and butter. Before attempting this technique, it is mandatory to read the test method in its entirety. This presentation is simply an overview or a summary of %ASH. The good laboratory practices associated with safety and personal protective equipment represented in this video are simply the safety requirements of the FAPC Analytical Services Laboratories. Furthermore, all samples received by Analytical Services are considered to be for testing purposes only and not for human consumption. Therefore, food safety and handling procedures do not apply. We urge you to determine what specific good laboratory practices and particular safety requirements are necessary for your own applications. Some of the recommended guidelines for good laboratory practices include: take measures to maintain the integrity of the samples throughout the process by limiting exposure to air and non-suitable storage temperatures, wearing gloves when handling samples and items associated with the test to prevent cross-contamination. Oil, moisture, or any other material on bare hands can affect the sample integrity, thus resulting in inaccurate data. Keep samples clearly labeled from preparation to disposal. Record observations at the time that they are made. Exercise safety precautions at all times by using the specific safety supplies listed in the method. In addition to the supplies required for the %moisture portion of the test method, the following items are necessary: thermoscientific type 6000 furnace, analytical balance, desiccators with dry rite, heat-resistant gloves, oven tongs, latex gloves, safety glasses, lab coat. Although there are no standards or reagents required for this analysis, the use of a control sample or a standard reference material is strongly recommended. The type of sample to be analyzed for %ASH will determine the analysis conditions. The specific analysis conditions must be selected according to the official method that better suits the sample matrix. Here is a chart with the method applications and test condition variables. The sample type will dictate the amount of sample that will be weighed, the furnace temperature setting, and the length of time the sample will be held at that temperature. Times, temperatures, and sample weights may be varied, if necessary, to correspond with similar official methods better suited for the sample matrix. Exercise extreme caution when working with the oven and the muffle furnace. Use heat-resistant gloves and tongs when handling sample containers. Before a sample is analyzed, it must be properly prepared so that an accurate test result can be obtained. This is achieved by homogenizing the sample. Homogenization ensures that all of the sample material will be of consistent content throughout and suitable for analysis. For details, please refer to Preparation of Test Samples, Analytical Services Method Number 1. It is recommended that all samples be analyzed in duplicate or triplicate for accuracy and statistical analysis. Place the dried samples in the cold muffle furnace. Do not stack the crucibles on top of each other. Close the door and turn on the furnace. Use the sample conditions chart to determine the temperature and holding time for the type of sample being analyzed. Refer to the Thermoscientific Type 6000 Furnace Operation Manual to set the ramp rate, holding temperature, and holding time for the sample type. At the end of the required time, after the furnace has cooled, use tongs to remove the crucibles from the furnace and place them in a desiccator under vacuum. Because cooling of the furnace will take several hours, it may be more practical to leave samples ashing overnight. Allow the samples to reach room temperature by leaving them in the desiccator for a minimum of 30 minutes. Release the desiccator vacuum very, very slowly and carefully. Releasing the vacuum too quickly will disrupt the contents of the crucibles, and ash may be lost, thus resulting in inaccurate % ash results. tare the balance. Using tongs, remove one crucible from the desiccator and place it on the balance. Immediately replace the desiccator lid. Record the crucible ID and the weight of the ashes and crucible. Continue the process until every crucible has been weighed and recorded. The first step in the percent ash calculation is to determine the weight of the ash remaining from the sample. This is accomplished by subtracting the weight of the empty crucible from the combined weight of the crucible and the ashed sample. The final step in the percent ash calculation divides the ash weight by the sample weight and multiplies the value by 100 to convert it to percent. As an alternative to manual calculations, an Excel spreadsheet may be used. Here is an example of what a spreadsheet should look like. The sample IDs, container IDs, and weights can be entered as they are observed. With the correct calculation cells set up in advance, the calculation is completely automated and occurs as data is entered. Calculate the average of the replicates from the percent ash results. This will be the reported result. For the statistical analysis of the replicates analyzed, calculate the percent relative standard deviation, percent RSD. The percent RSD should not exceed plus or minus 5%. When applicable, the measurement uncertainty should be included with the result.